Welcome back to RamZland. Today I want to explore whether glass is an insulator, a conductor, or perhaps both. Check this out. For this investigation, I'm using a block of styrofoam, needle nose pliers. This is a little handheld torch. I've got some small Pyrex test tubes that we're going to heat up, some copper wire, and this is a socket extension cord with a clamp, and I'm using a 30-watt light bulb. The first step is to separate your socket extension cord and then remove the insulation from the ends of one side of the cord so it looks like this. Next, take your copper wire and prepare 2 electrodes that are about 6 inches long. And bend each end of the electrode so it can wrap around a small glass tube like this test tube here. And I'm just gonna make it so that test tube can fit through fairly tight. So it's like that. So you want 2 of these. And then finally, I'm just sticking both electrodes into a styrofoam block that'll serve as an insulator. And if you don't have a good connection to the glass, just turn your loop a little bit so there's just enough pressure on the glass so when we heat it up, it can provide some conductivity. Now you're going to take the 2 exposed ends of your socket extension and you're going to wrap them around each side of your electrode on the base of the styrofoam. So it should look like that. Okay, so right now you'll notice that the light bulb isn't on. That's because glass is working as an insulator, but if I connect the 2 electrodes with this screwdriver, you'll see that the light turns on. Now, what will happen if I heat up the glass to its melting point? Will that affect whether or not the glass is an insulator or a conductor? Let's find out. Still not light yet. There it is. All right, let's let it cool. Let's see what happens to the light as the glass cools down because it's at its melting point right now. Light's still on and it's out and our glass is cooled. So what happened? When the glass reached its melting point, it became a conductor, but when it cooled, it turned back into an insulator. How's that possible? Well, this molten glass is actually called soda lime glass, and that's because 70% of it is made of silicon dioxide, but about 15% is made of sodium oxide, and the other 15% is made of calcium oxide. And so when this gets to its melting point, instead of being an insulator, it becomes a conductor because it's so hot that those sodium ions and those calcium ions can break free and become excellent charge carriers. And that's how electricity can pass from one electrode through the sodium and calcium ions in the molten glass to the other electrode, thereby completing the circuit and turning on the light bulb. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.